Hello, I'm in the Pilot's Handbook of Aeronautical Knowledge. I'm on 4-4. This will be drag, right after thrust. Aerodynamics of flight, drag. Drag is the force that resists movement of an aircraft through the air. There are two basic types, parasite drag and induced drag. The first is called parasite drag because it in no way functions to aid flight. While the second, induced drag, is a result of an airfoil developing lift. Parasite drag. Parasite drag is comprised of all the forces that work to slow an aircraft's movement. As the term parasite implies, it is the drag that is not associated with the production of lift. This includes the displacement of the air by the aircraft, turbulence generated in the airstream, or a hindrance of air moving over the surface of the aircraft and airfoil. There are three types of parasite drag: from drag, interference drag, and skin friction. Form drag. Form drag is the portion of parasite drag generated by the aircraft due to its shape and airflow around it. Examples include the engine cowlings, antennas, and the aerodynamic shape of other components. When the air has to separate to move around a moving aircraft and its components, it eventually rejoins after passing the body. How quickly and smoothly it rejoins is representative of the resistance that it creates, which requires additional force to overcome. Wow. Notice how the flat plate in figure 4 causes the air to swirl around the edges until it eventually rejoins the downstream. Form drag is the easiest to reduce when designing an aircraft. The solution is to streamline as many of the parts as possible. Let's look at that. Flat plate. Sphere. Sphere with a fairing. Sphere inside of a housing. Alright. Interference drag. Interference drag comes from the intersection of airstreams that creates eddy currents, turbulence, or restricts smooth airflow. For example, the intersection of the wing and the fuselage at the wing root has significant interference drag. Air flowing around the fuselage collides with the air flowing over the wing, merging into a current of air different from the two original currents. The most interference drag is observed when two surfaces meet at perpendicular angles. Fairings are used to reduce this tendency. If a jet fighter carries two identical wing tanks, the overall drag is greater than the sum of the individual tanks because both of these create and generate interference drag. Fairings and distance between lifting surfaces and external components such as radar antennas hung from the wings reduce interference drag. A wing root can cause interference drag. Skin friction drag is the aerodynamic resistance due to the contact of moving air with the surface of an aircraft. Every surface, no matter how apparently smooth, has a rough, ragged surface when viewed under a microscope. The air molecules, which come in direct contact with the surface of the wing, are virtually motionless. Each layer of molecules above the surface moves slightly faster until the molecules are moving at the velocity of air moving around the aircraft. This speed is called the free stream velocity. The area between the wing and the free stream velocity level is about as wide as a playing card and is called the boundary layer. At the top of the boundary layer, the molecules increase velocity and move at the same speed as the molecules outside the boundary layer. The actual speed at which the molecules move depend upon the shape of the wing, the viscosity, the stickiness of the air through which the wing or airfoil is moving, and its compressibility, how much it can be compacted. Wow. The airflow outside of the boundary layer reacts to the shape of the edge of the boundary layer just as it would to the physical surface of an object. The boundary layer gives any object an effective shape that is usually slightly different from the physical shape. The boundary layer may also separate from the body, thus creating an effective shape much different from the physical shape of the object. This change in the physical shape of the boundary layer causes the dramatic decrease in lift and an increase in drag. When this happens, the airfoil has stopped. In order to reduce the effect of skin friction drag, aircraft designers utilize flush mount rivets and remove any irregularities which may protrude above the wing's surface. In addition, a smooth and glossy finish aids in transition of air across the surface of the wing. Since dirt on an aircraft disrupts the free flow of the air and increases drag, keep the surface of an aircraft clean and waxed. Alright, we'll hold off there. There's 4.4 into page 4.5. That was just interference drag and skin friction drag. And yeah, now we're going to go into induced drag. See ya.